Welcome to this explainer. If you are an automation developer trying to reliably navigate protected forms or logins, you are exactly in the right place. Today, we're walking through the exact engineering blueprint for building resilient, production-grade CAPTCHA automation right inside Deno Deploy. Let's jump straight into it.
Here is a quick look at what we are covering today. We'll start with the unattended automation problem, move on to the core solving workflow, hit our operational checklist, look at some common integration mistakes, and wrap up with a quick operations FAQ.
All right, part 1, the unattended automation problem. Because we really need to talk about why scripts that run perfectly on your local machine suddenly just break in the wild.
You know the feeling, right? Solving CAPTCHAs from Deno Deploy seems so incredibly simple during a quick test. You run a script locally, maybe in a notebook, it works in 5 minutes, and you're like, awesome, we're done. But the reality? That's a whole different story. Your code actually has to live in an unattended environment. We're talking CI pipelines, cron jobs, scheduled jobs, internal queues, or just really complex automation flows. A happy path demo is nothing like a production environment that has to survive deploy windows, random network hiccups, or sudden changes to the CAPTCHA on the page, all without you there to hold its hand.
Moving right along to part 2, the core solving workflow. To actually survive those harsh realities, we absolutely need a standard operating procedure.
And here is that exact procedure. It's a 5-step workflow that gives you a super clean, predictable integration. Step 1, capture the required CAPTCHA inputs. Nothing more, nothing less. Step 2, submit the task. Step 3, pull for your result. Step 4, and honestly, this is where a lot of people mess up, apply the token. And finally, step 5, verify downstream acceptance. Stick to this structure and you are guaranteed to get predictable latency and, just as importantly, really clear failure modes.
Okay, part 3, the operational checklist. Think of this next section as your ultimate code review checklist before you merge any integration to production.
First things first, always confirm your workflow is actually authorized. Second, capture only the required inputs that the challenge expects, stuff like the site key, page URL, action, method, and maybe an optional proxy. Capturing anything extra just creates these messy, false debugging trails. And third, you've got to treat failed API responses as real errors. Any non-one API status code, that is a hard error. Surface it immediately.
Next up is execution. You need controlled polling. So set a 15-second first, wait, a fixed 5-second interval, and a hard timeout cap of exactly 120 seconds. Now listen closely, because this is probably the most vital technical detail of all. You have to apply the solve token in the exact same browser context, HTTP client, or cookie jar that triggered the challenge in the first place.
Rounding out the checklist, make sure you track solver success completely separately from workflow success. Cap your retries so you don't end up in infinite retry loops. Log useful failure details, but please strictly ensure your secrets are stripped out. No API keys in the logs. And finally, keep a close eye on your monitoring. You want to track latency, retries, timeouts, downstream acceptance, and your cost per accepted solve.
Because, if you can't measure it, you can't defend it. Wire these exact KPIs straight into your existing dashboards. Your first solve latency should be comfortably under 25 seconds. That tells you the integration is healthy and not just spinning on retries. Your solver success rate needs to be 95% or higher, proving your inputs match the live challenge. And your end-to-end acceptance must also hit that 95% mark. Tracking these means you're going to spot regressions way before your users ever complain.
Let's jump into part 4, common integration mistakes. Because even with a rock-solid workflow, it is so easy to fall into a few known traps.
Mistake number 1, guessing CAPTCHA parameters. Never guess. Inspect the live page and pull the exact inputs. Mistake 2 is polling without a timeout. Always enforce a hard cap of 120 seconds. And the third big one is treating token delivery as full success. Delivering the token means absolutely nothing if you don't verify downstream acceptance. Always make sure the target server actually accepted it. Another massive pitfall is losing your session context. You trigger a challenge in one HTTP client, but submit the token with another? Yeah, that's going to fail. Keep the solve in the exact same cookie jar. Also, please stop retrying every single error. If you hit a hard failure, capos retries with exponential backoff so you aren't just hiding real system defects. And, as we mentioned earlier, never log sensitive data. Always strip those secrets.
Finally, part 5, operations and troubleshooting FAQ. Let's tackle the absolute most common operational questions developers ask once their code hits production.
Question 1. Why can a solved token be rejected? Honestly, this is by far the most common support ticket we see. You send a perfectly valid token. The solver gives it a thumbs up, but the target app just says, nope. So what gives?
Almost every single time, mismatched sessions are the culprit. Tokens fail when they're applied in a different browser session context or HTTP client than the one that actually triggered the challenge. If your Deno Deploy function opens a connection, gets a CAPTCHA, solves it, but then opens a brand new connection to submit the form, well, the target server literally has no idea who you are. The token and the session ID have to travel together.
Next question, how can teams keep the workflow stable? Because once your integration is live, you really want to avoid those late-night pages. Nobody wants to wake up at 3 a.m. because a cron job got stuck.
To keep things stable, rely on 3 main controls. First, wire your key metrics right into your existing dashboards. Don't build some totally separate monitoring silo. Second, absolutely cap your retries at 3 using exponential backoff. If it fails 3 times, trust me, it's a real error, not just a network blip. And third, set up intelligent alerts specifically to watch the gap between solver success and downstream acceptance.
Which brings us to our next question. What should teams monitor first? If you only have time to set up a few core indicators today, where do you start?
You've got to monitor latency, retries, timeouts, and, I can't stress this enough, that crucial gap between solver success and downstream acceptance. If your solver is humming along at a 99% success rate, but your downstream acceptance is sitting at 60%, you have a massive problem. It usually means your token delivery mechanism, like your session context, is fundamentally broken.
All right, last question in our FAQ. How can retry loops increase cost? This is an essential one for your operational budget as your automated flows start to scale up. Here's the deal. When automation scales, your volume scales linearly with successful solves. That's totally predictable. But infinite retries? Or loops where you're just firing off the wrong parameters over and over? Those will absolutely burn through your balance without ever fixing the root defect. You're literally paying for computation and API requests that are guaranteed to fail. So capping retries isn't just an engineering best practice, it's a financial necessity. Now, before we wrap up, we need to talk about a critical safety note. This type of workflow should only be used in owned, client-authorized, or contractually permitted environments. Period. This architecture is specifically engineered for predictable integrations in authorized environments, meaning you own the app, or you're operating it for a client who gave you the green light, or you have a clear, authorized data collection agreement in place. And that brings us to our final takeaway. A Deno Deploy CAPTCHA workflow must be treated like production infrastructure, not a happy path demo. By capturing exact inputs, respecting session context, and enforcing strict timeouts, you take a fragile script and turn it into a truly resilient system. So taking a look at your own code base right now, how are you going to apply this blueprint to ensure your next automated workflow actually survives the realities of production? Thanks for tuning into this explainer. Happy building.